Okay, so this lesson we are looking at solving simultaneous equations graphically. Okay, so before I get into it, you will also notice that there is an exercise in your textbook 5D where you solve simultaneous equations algebraically. That's actually not in the standard syllabus. Okay, so it may have been when they wrote the textbook, but they have made amendments, meaning that the only way that you need to be able to solve simultaneous equations is graphically. Okay, you don't need to use it algebraically. So we will skip 5D. So if you're wondering where the 5D video is, it has been skipped, meaning that only questions you're going to get are graphically. So it's really important that you understand this exercise. Okay, you also need to be able to use, according to the syllabus, to solve those equations with and without technology. Okay, so when you get to those questions in your textbook that ask you to do it with technology, please don't skip them. Okay, when you are solving with technology, a really good online graphing software is Desmos. Just write it there. Where I will in a second, after I explain this example, I may show you, we'll show you that exact same, not Desmon. Okay, I will show you the exact same example using Desmos so that you can see how it works. Okay, now the learning intention for today is to find the solution of a simultaneous linear equation, of simultaneous linear equations graphically. Now when you're finding a solution, this is you're finding the point of intersection. Okay, that is the whole point of this. You're finding out where those two equations cross. Okay, so two straight lines that are not parallel will always intersect. So the only two lines that don't are parallel lines, because they're like train tracks, they never meet. Every other two straight lines will meet at some point, even if it doesn't look like they will on your graph. If you were to extend them out, they will. The point of intersection can be found by drawing the two straight lines as accurately as possible and reading the coordinates of the point of intersection. The point of intersection could also be determined by looking at the table of values for both functions. Okay, so let's have a look at this example. Find the simultaneous solution of y equals x plus 3 and y equals minus 2x. Now I'm not going to use the table of values. I'm going to use the gradient intercept form. Okay, so remember, y equals mx plus b. This is my gradient, this is my y-intercept. Okay, so for the first equation, y equals x plus 3. My y-intercept is at 3, and my gradient, this one's hidden, I guess. It's a number in front of the x, so in this case it's 1, okay? So needs to be rise over 1. So in this case it's 1, so you put it over 1. Okay, so that you have something to rise and something to run. Okay, so I'm going to do this equation in purple, so it stands out. Starting always with your y-intercept, so at 3 I'll put a cross, and then I want to work with my gradient. So rise means I'm going to go up by 1, and then run means I'm going to go left to right 1. Because it's positive, I'm going to the right. It's going to bring me to here, and there's my second point. So that equation, using your ruler, is something like that. Okay, let's just get them to intersect properly. And you want them to intersect properly so that your intersection point is very clear. Okay, and don't forget you should label your equation. So y equals x plus 3. Okay, next one, I'll do it in green, is y equals minus 2x. So y equals minus 2x. Now here there's no y-intercept that's really clear. That means it's at 0. Okay, so b is at the origin, and my gradient here is minus 2 over 1. Okay, so in green, starting at your origin, which is down here, my rise is 2, so I'm going to go up 2, 1, 2, and because it's negative, I'm running to the left. So it brings me over to here, and that's my second point. Okay, Oh, that's really off. Gotta fix it up. Alright, so that's my point of intersection, and that one's moved again. Alright, so from that graph, now I've graphed both of them, so what I have to do is identify that point of intersection. So in this case, the point of intersection is here. Okay, so the point of intersection. Okay, and that is at -1 and 2. So you need to graph those coordinates. So x goes first, y goes second. So therefore, y equals x plus 3 and y equals -2x intersect at -1 and 2. Okay, so that's that example. So only one example for today. I did say I was going to do that on Desmos now. So, alright, so if we go to Desmos, I don't know how good this is on the iPad, we'll give it a go. Start graphing. Alright, what you have to do here is type in your two equations. So, y, it's a lot easier with a keyboard. Y equals x plus 3. Okay, so that's the first one. Then just down here, you can put as many graphs as you like. So this is also handy when you're doing your homework and you're not sure if your graph is looking correct. You can always chuck it into Desmos. Y equals -2x. Okay, so there's our equation. So the more you zoom, the intercepts will change and get more and more accurate. So you will see, I haven't got a pointer on this, but you should see that they intersect at -1 and 2. And that's what we said in our equation as well. So it's exactly the same sort of thing. Alright, so hopefully that's nice and clear for you. Make sure you're using a ruler and you are drawing your axes very neatly and evenly. You want your x and y axes to be evenly spaced so that your point of intersection is very clear. Okay, thank you.